Okay, so dispense with the pleasantries. We know what this is. Organic 2. Um, I want to just go over kind of most things are sort of the same as they were last semester, which isn't helpful if you weren't here last semester. So let me just go through the two places where you're going to get the information for this class. The first is Canvas. So when you're looking at Canvas, we have there'll be a little video on start here on how to negotiate things, and that's what I'm going to kind of go over now. But I'm going to make a shorter one for that space. So first thing is, if you need help with anything, there are now links to information services, Canvas, Top Hat, and I suppose any of the operating systems that you have. This was suggested it's a good practice to have this stuff available online. So if you need it, that's where it's at. You can make an appointment with me for the calendar in 15-minute increments. And so a lot of you know how to use that. Just click on that link and it'll take you, and you can choose when I'm available. The course syllabus and the lecture. And so there's extra stuff on my screen that's not going to be on yours. Anything that doesn't have a green check mark is not on yours. So the important thing here is the syllabus, obviously, and then the lecture schedule. So the lecture schedule as a whole is on here for every day. I'm transferring that into each day so that when you open up a folder for the day, the first thing you'll see is what sections of the textbook are we going to talk about and what topics are we going to look at. But if you want to print this out, you can print it out and keep track of it. Otherwise, it's going to be directly in each day's folder. So then if we go to a day's folder, we have all of the 221 exams, except last semester, which I'll move on to them, and then also all of the previous this semester's exams. So you use those as practice problems or practices and GAMS. There's a lot of them available. So if we go to today's folder, the first thing you'll see the reading assignment. That's going to tell you in the Top Hat textbook what the subjects for today will be. And we'll look at some of these. Now, I'm going to return to a more traditional kind of flipped lecture for this semester, meaning that for most of the periods, there will probably be a video that you could watch before coming to class, as well as you could read the textbook. For some, because I don't quite have everything matched up without making a new video yet, for some things I'll probably just live lecture. And so there won't be a video to watch. There'll still be the book to read, but if you want to do that before you come to class. But you can read before or after class. That's really going to depend on your own learning style, but you got to do one or the other. You just can't totally ignore the textbook. You can ignore the videos if you want, but the textbook is going to be important. So, for instance, for today, there's a series of PowerPoint lecture notes, which all of you have, except a couple. Or if that's not the one that ran out, it's probably the one for Wednesday that ran out. Then I brought today's and Wednesdays. I said I'm a couple short on Wednesdays, so I'll bring some extra on Wednesday to class, or you can print them out. So we can open that up. If you want to open up the video, you can open up the video, the class video that goes with those notes and goes with those topics, and it will take you to this. It will take you there. And so it'll give you that video, and for the most part, the videos will match up with the material for that day. I set it up that way. And so you can do that. And then you can watch that video. Now, I'm going to caution you, maybe 1.5 times might be, enough for that. That's probably the maximum speed you'd want to use. What set me into Top Hat last year was people were watching it at like 2 times the speed. And I can't watch it at 2 times the speed. Remember, the whole purpose of these videos, watching them either before or after class, or reading the textbook before or after class. It's not a checkbox, oh, I'm done, I can move on. It's watch the video, and then as a real lecture, take notes on it. Man, I don't want to go faith here and walk around and look at all of your lecture notes that you've taken from the video. I don't want to be pushed to that extreme. But I guess if I am, then that's something I might have to do. But honestly, if you go through here, we can spend time in class on the stuff that's the hardest, and then the stuff that isn't the hardest, we can kind of leave be. So when you watch the video, watch it as if it's a true lecture. Like I said, maybe at 1.5, but remember, it's content that's important. And if you want to watch it beforehand or read the book beforehand, I would strongly encourage you to do one of those two. And then after class, do either one or both of those. So that way you can go about, okay, here's what we did in class. I remember this. Oh, we didn't do this. Well, maybe I should ask them if that's important. Answer's probably going to be yes. But, oh, I don't quite understand this. Okay, ask that question to begin with in class. Okay, so that's what we want to do with the lecture video. So those are linked to my YouTube page, but they're linked off of each folder. And so in a traditional flipped lecture, what I would have you do is watch that and then come to class. And that's kind of what I'm encouraging here. But if you don't want to watch the video, you could read the sections of the textbook, of the Top Hat textbook as well. Or you can do both. Either way, I'm going to hope that you do both within 24 hours after that class period. Then what you're going to see is after that, you're going to see some problems. Now, this semester, what I've decided to do is, I guess last semester I underestimated all the electronic homework problems that we were going to do. Like at the end of each chapter versus in the chapter. Too much. So what we're going to do this time is you're going to be required to do the problems in the text as you read it. And then for some additional problems, I will have handwritten ones that you'll do and turn in. And the first one that's due Friday was over there. So I'm going to give homework problems that are take-home homework problems. And we're also going to have many more start of class quizzes this semester. And they will probably be written as well. Occasionally I might use the Top Hat system, but but they'll be written out. So that way we're more closely emulating what's going to be on tests. But it'll still be a mix. Okay. I did release the end of chapter homework problems for you to do as review. So I released everything at the beginning, so that way I don't have to worry about, did I change? There are no due dates on these because due dates cause things to disappear, and I don't want them to disappear. So I will put the due date online, and that's when I'll go through and I'll write down your score. Okay. So does that mean, today's lecture went through 13.4 or something like that? If you're going to be on top of things, you want to do those problems after class, before the next class, you want to do those problems in the chapter that are in those sections. If you want to wait until the last day, you can go ahead and do that. Again, I wouldn't suggest that. I'd suggest working on them as you go through. And then I think I'll have it scheduled where like 2 periods after we finish a chapter, that's when the class problems will be due. So I think we're finishing up this chapter on Wednesday. So that would be Monday of next week. But since we don't have class on Monday, they'll be due on Wednesday. And I will put that online so you see it in your lower right-hand corner of Canvas saying this is due this date, this is due this date. Things are pretty organized right now. I give it till tomorrow. And then it's going to become exceptionally unorganized. But at least today, everything's good for the moment. Okay. And so you'll see on Friday the 18th, homework problems. And those were the ones that were just a single page. Now, sadly, this is Organic 2. And unfortunately, Organic 2 means that we need to remember Organic 1. And I could just assume that we're going to go back and review the stuff that you don't remember on your own. But let's be honest, you're going to need a little help. So in the homework, I've given you some practice problems from Organic 1, about 104 of them. And they're all multiple choice, and I'll give you the Scantron on your way out after class. But those problems, they started out by being the problems that were missed the most on the final exam, so it's not everything. I mean, there's no determining R and S, but you can go, but this will get you started in terms of remembering and reviewing Organic 1. If it's not quite on the top of your head now. And my experience is we need some work to get back into that. So that's due next Wednesday as well. And if you have questions on them, you can ask me. This is, again, it's like a take-home quiz, the same as we're going to be having before every day. So, but it is a good review, I think. And if you have to go back and look at your notes from last semester, that's okay. You could also go back and look at the textbook, which I'll get to in a minute, because everybody has the copy of the entire textbook. And for those of you who weren't in last semester, I will give you access to the Canvas site from first semester. I haven't done that yet because I haven't tried. I have a suspicion when I do that, somebody's going to tell me I can't, and so then I got to go to ask somebody to give me permission to do that. Okay, so that's there. And then the other things you might see these practice problems. They're totally practice problems. They're not going to be graded, but there's an answer key. So if you want to do additional problems, they're there. I may use some of these in class. I might even use them in take-home quizzes. Which if I do, then I guess there's a narrated answer key for it. You just have to search for it. But I'm going to use some of those. There's also on mine, you might see there's a pre-lecture quiz. This is an online quiz that I use, that people would watch the video and then they would take this. I will probably use some of these questions and have you click in your answers using the Top Hat Classroom. So those will maybe come about, but after you read the textbook or watch the video, in the textbook at least you have problems to do for the homeworks. And the percentages of these are all listed in the syllabus. So some of these practice problems, sometimes there aren't any practice problems, sometimes there's a couple of sets, it depends. Okay? So that gives you additional problems to do. So then for Wednesday, if we looked at Wednesdays, the reading assignment is there. It's going to be the rest of chapter 13 from Top Hat, and then there's the notes, which were printed out over there, except for a couple of them. And then there's a video that goes along with those. And then I didn't want to do that. And then there might be some practice problems and stuff. I'll release these at least before the beginning of the class. So if we have class on Friday, I'll release these hopefully before the beginning of class on Wednesday. There are going to be some things like on Friday, there's no video because that material doesn't match up with what I have. So what I may ask you to do is to go through the book and then I'll live lecture on that. I will always start each class period with, do you have any questions? After any quiz that we have. And then if you have questions, I'll answer as many questions as you want. And if you want to give me questions for the entire period, I'll answer them all. Otherwise, we'll start incorporating some problems. Sometimes I might ask problems at the beginning of class just to see if because nobody asks questions, right? And I don't get that, but that's okay. If you want to ask questions and you're super shy, I might have some 3x5 cards with me now. You can take a 3x5 card and you can write it down and then put it on the desk before I get here. You can probably just put it on the desk in front of me, like I'm going to remember who gave me the cards. But if you want to do that, that's fine as well. I know when you're watching a video, you don't have anybody to ask questions to. That's why I suggest write down the questions and bring them to class. Okay, so that's for Friday. There won't be a lecture unless I record one for Friday, which at this point is unlikely. Okay, so there's going to be some times when I'm live lecturing on a topic. All right, so that's the Canvas part. The Canvas part has the link to the videos. The Canvas has the take-home quiz or take-home homework problems, and it has the reading assignments for Top Hat, and any PowerPoints, and then any practice problems. Okay, so everybody kind of see that in terms of what's on Canvas. So then we go to the textbook, which is Top Hat. And so a couple things, because I had to work this out with the company of how it would happen. For those of you who had access to the Organic Chemistry 2 or Organic Chemistry text last semester, you still have access to it, I think. But what happens is if you purchased a year-long subscription, your code is this one, the 703532, and I think I sent out an email for that. So when you go in to load that code, it'll say, oh, you have a year subscription, and it'll give you access to that. If you didn't, then you're going to get access to that site. Now, there's two things you need. You need the electronic book, and then you need the classroom, the Top Hat classroom, because that's how we answer questions. I push them out to your mobile device or your computer, and then you answer the questions. And if you don't have a tablet or a computer, I have a couple, and I will have a couple with me. So you can go ahead and borrow one for the class. And this setup is a little bit easier for computers and stuff than last semester. So then your section is the 703532 section. Now, that textbook is the entire textbook for the year. It looks like they copied everything over from one of the previous sections, because in the textbook, it actually still has some of the questions that I did in class that are there. I don't think it has all of them. I've got to figure out what's missing. So we're not on chapter 26 yet. That'll be like the last day of class. We'll do that entire chapter. Or not. So some of the questions are there that you could go back and take a look at. And when we so what I've done is for the previous first 12 chapters, I've given you access as practice. So I think you can go back and do the problems. You just see they're not graded. From chapter 13 on, then you can see that the red means that it's a homework problem. The orange means that it's practice. So I've given you practice for the end of chapter problems. And again, I may use some of those in class as well. So we could go to chapter 13, and there's like 15 questions in this chapter, and then you can go through and do the reading. I may edit the chapter and add some things, but I'm not going to try and put links to the videos in this semester because I didn't have enough time to do that last semester. But this will be the textbook, and you can go ahead and read. For a lot of this, it's going to be very similar to what I do in the lecture video. There's not that many ways to present this material. And then you'll go, there's a lot more of the keeping it real stuff, which is their attempt to relate this to real life. Because after all, it's like, why am I taking this? Why am I teaching this? But for instance, like with triple bonds, they have the cholikomycins. There's a whole bunch of myosin drugs that are antibiotics and anti-tumor. A lot of them come from various amphibians or corals. And so, unfortunately, when you take those materials like the corals or sea urchins or stuff like that, they don't make it. And so you basically extract all the compounds out of them, and there's all of these myosin compounds. And their point is that in this big long ring here, which is bigger than anything we talked about last semester, there's 2 triple bonds, and that's an important feature. Having the triple bond and the double bond in that ring is this common structural factor of the myosin. So it's just applied to the real world. It's an ene-diene, which, if you remember the naming from last semester, would be 1 double bond and 2 triple bonds. Josh?
In the previous picture, when we were talking about the myosin, is that the triple bond that's higher in the picture? Is that attached to the carbon with the OH group on it?
Yes, it has to be,
okay.
Because otherwise that carbon's got 6 bonds.
So confused.
Yeah, no, it's connected underneath the ring. Yeah, I saw that this morning. I'm like, 6 bonds, good. We've dispensed with the only 4 bonds to carbon rule for second semester. No, we've not done that. In lab, you're going to be running some primary carbocations, but that's as far as violating my rules goes. And there's a good reason for that. So anyway, in the textbook, if you have questions about any of the problems, feel free to ask them in class. We can kind of talk about those. Now, I've given you two chances on the problems, and then you'll see the correct answer. So I already coded all that stuff in to the chapter, so I wouldn't have to worry about it. Like I said, that level of organization is going to disappear very quickly, but at least it's there now. Okay. So this is the electronic book. When you have access to the classroom, what I will do is I will send a question out, and it'll show up on your phone or your tablet or your computer, and then you'll answer that question. It's basically going to be a clicker system. I may use the drawing a little bit more. I don't know how easy it is to draw on a computer compared to your finger on the phone, but we may do some more drawings. Or I may just draw the structures out and say choose A, B, C, or D. Or multiple answers. Okay. So that's the electronic book, and as you know, and the ideal situation here is that you watch the video or read the sections of the textbook before you come to class. And then in class, I'll answer questions. If any questions come up, we'll go over those. And then after class, you're doing whatever you didn't do, whether it's read the textbook or watch the video, or both, or going back through sections. I'll still record each lecture video so that you could go back and hit the part that you need if you zoned out. Or said, did he really say that? That's probably more likely. Did he really say that? It's possible, yes, for anything. So that's what you want to do. Okay. And then the problems, the homework problems that I handwrite will be due the next period. That'll all be listed on the paper and online. There will be an answer key for that, maybe narrated if I have the ambition to do that. So, and then for quizzes, we won't have any quizzes, beginning of class quizzes this week, but we may. So we'll start next week. And if I don't give those like every day, then I stop, and then the end of the semester's here. So I have to do it every day, or I just stop. So we want to have more of those this semester. So the only thing that's going to be really different from last semester is that I'm going to be giving you more of my problems for practice and for homework problems, and you won't have to do the end of chapter electronic ones.
Are the problems that you hand out to us going to be graded on accuracy, or is it more of a completion?
No, it's more accuracy.
What about the packet?
The packet?
The 100 questions.
Oh, absolutely. You're getting a score out of 100 for. You get a score out of 100. I'll give you 4. I'll give you a curve of 4. But it's due next Wednesday, but next Wednesday will be here like that, right? Because we got a day off, and then I'll do them on my day off, and it'll be like when I have time off, I've already got 4 things packed into that only had enough space for half of one. So you want to make sure that you start on those. But the whole idea here is to get you reviewing, is to make sure that we've got a decent amount of 221 in here before we start 222, because as you'll find out here in a minute when I start on the alkynes, I'm going to ask questions like, oh, what is this reaction, SN1 or SN2? And so if you're sitting there going, what is he talking about? That's not good, right? Since I've had most of you, it'll hurt my feelings if you don't remember anything from last semester. Like that matters. But no, I want to make sure that everybody's kind of reviewed, because we're going to be reviewing a lot this semester. And reactions, we're going to be doing a lot of reactions. I mean, could be 6 reactions a day. Okay. So, and maybe on Wednesday I'll talk about, maybe give you my idea of how you can organize those. But you're going to have to come up with a way to organize them in here and on paper. So maybe flashcards, etc. Okay. So those are the 2 big things, Canvas and then obviously the Top Hat. And we're not going to use the Top Hat classroom system today. We'll use it maybe on Wednesday and then into Friday. Okay, any questions? All right, so syllabus week is only for freshmen, their first week of classes, ever. We pretty much get out of syllabus week very quickly. This was actually a long time, but I just want to make sure everybody's kind of on the same page. And I learned a lot about using Top Hat last semester. I probably learned more about what not to do or how to use it poorly as opposed to how to use it better. So hopefully it'll be a better experience this semester. Okay, alkynes. So when we talk about alkynes, we're talking about triple bonds. And there's actually quite a bit that we know about triple bonds than we would think. So here are, because when you have a triple bond, you only have 2 places to attach alkyl groups. When you have the triple bond at the end of the chain, that's called a terminal alkyne. And when the triple bond is not at the end of the chain, that's called an internal alkyne. And that terminology could have been used for an alkene as well, but it's definitely used for triple bonds. So then my question would be, which of these 2 triple bonds is more stable? How many people say terminal? And you're going to have to raise your hands today. Internal. Okay, why is the internal one more stable? Josh?
There's a concentration of electrons that are being able to stabilize bonds from the alkyl on each side as compared to only one in the terminal.
Okay. Could somebody restate that? More substituted. Which leads to all of your all of the electrons pushing into the triple bond. Triple bond loves to get electrons pushed into it the way we push electrons into it, at an alkyl group. So an internal alkyne, because it's got two alkyl groups, is more stable than the terminal one. Okay. So one of the every chapter is we're gonna talk about, actually not with the Top Hat book. We normally start with naming, but we did all of our naming in the first month. So we're going to talk about physical properties. We're going to talk about how you make that triple bond, and then what reactions you do with the triple bond. So in terms of physical properties, just a couple of the big ones. The triple bond, because the carbons are sp hybridized, means that the triple bond is linear. And so that's the shape of a triple bond, is it's linear. And that means that it's, for a triple bond, it's hard to have steric hindrance when things are linear. It's gonna be very difficult to make those sterically hindered, but we'll find a way out on Wednesday. And the other thing is that I've got two pi bonds. So one of the things we have to remember about pi bonds are that pi bonds make the molecule a nucleophile. So if you think about all the pi bond reactions that we did in chapter 12 last semester, what did we have? We had HX, H plus H2O, hydroboration oxidation, hydrogenation, bromination, bromohydrin formation. Right, we had ozanolysis where we cleaved it. Right. So we had all those reactions and more that I'm not saying. Well, guess what for triple bonds? We have those times 2. Because we've got 2 pi bonds, that means we can do everything twice. Okay. So if you're sitting there going, what were the reactions that he just talked about with the double bond? Well, that's why we have review. And so if you get those reactions under control, you'll be good for the triple bond, because we're going to do those reactions again. And then the opposite of that, well, you can figure out what the opposite of that would be. If you don't know those, then triple bonds are going to be a nightmare. So we need to go back and remember all those reactions. Okay, but when we first start with say, okay, how do you make a triple bond? And most textbooks start with saying, okay, I can make a triple bond by taking a terminal alkyne, reacting it with a base. And if I do that, my base will deprotonate my hydrogen to make what's called an alkynyl anion. And then the base gets terminated. Now when we start looking at an alkynyl anion, what is it? It's a strong nucleophile and also a strong base. So this is both a strong nucleophile and a strong base. Which means that if it's a nucleophile, what kind of reactions can it do? Can it do? That doesn't sound right. It can do SN2 if it's strong. We could do SN1, but primarily it's going to do SN2. And then when it's a strong base, it's going to do what reaction? E2. So it can either do SN2 or E2. Right. And so this is going to be one of our anions where we have to think about what's it going to do. Is it going to do SN1 or SN2, or is it going to do E2? It's going to depend on the halide that it's reacting with. So for instance, if I said, you know what, let's react this alkynyl anion with a primary halide. What kind of reaction is it going to do? To what?
Nucleophiles, no reactions with them.
Well, we just said this was a strong nucleophile.
Yeah, so that's
SN2? Do we all agree on that? Okay. So it's going to do an SN2 reaction, which means it's going to come in, attack that carbon, kick off the chlorine. It's going to go through its trigonal bipyramidal geometry, which I'm not going to write down here, but which you'll write down in the homework assignment. And then I'm going to add a CH2CH2CH3 group to the other side of the alkyne. So this is called an alkylation reaction. And as an alkylation reaction, that just means you had an alkyl group. So we know primary alkyl halides can undergo SN2. What other halides can undergo SN2? Primary and secondary. Okay, so if it's either a primary or a secondary halide, it's going to undergo SN2. Bless you. What about a tertiary halide? Let me hold that question for a second. I didn't say what base to use. It forms a C minus, and in general, C minus is the strongest base you can have. And so in order to make a C minus, you need to use a base that's stronger than C minus. Well, if a C minus is the strongest base that we have, it doesn't seem like I have a base strong enough to make a C minus. Now, actually, I do. I can remove hydrogens off of benzene rings. I don't think I can remove them from alkanes, because an sp3 hybridized carbon with a negative charge is the flat out strongest base I can make in this class. But a triple bonded C minus is actually a little bit less basic than an sp3 hybridized negative charge. So I want a really super strong base here, and my super strong base is going to be NH2 minus. So NH2 minus is the base that I use. It's a small, non-sterically hindered base. So last semester we used this in E2 reactions, and the product was the most stable double bond. Right, as opposed to our other base that we used, which was this one, which was our tertiary butoxide. Tertiary butoxide will not deprotonate this CH. I've got to use an N minus to do that. So this is called a preparation of an alkyne. I don't consider this really to be a good way to synthesize an alkyne, because in order to make the alkyne, I needed an alkyne. And when I think of I want to synthesize this functional group, I want to do it from scratch. So this is kind of cheating. But it is a way to add an alkyl group to the end of the triple bond. So if it's primary and secondary, no problem. We just react it like an SN2 reaction. Everybody okay with that? So what happens with a tertiary then? So if I had that same triple bond, and I now added it to a tertiary chloride, what's the reaction going to do? You know, I could do SN1 if there was enough time to lose the chloride and then have the strong anion or strong nucleophile react with the carbocation. But actually what happens with this strong nucleophile is it's not going to do SN1, it's going to do E2. It's going to act as a base. So, sometimes I like to give the molecules human characteristics, which, isn't possible. But if they had them, these are the characteristics they would have. Strong nucleophiles are both strong nucleophiles and bases. They have kind of a split personality. Their primary personality is nucleophile. They're going to attack. And they're going to do SN2. And if they're prevented from doing SN2, we can give them the human characteristic of getting angry and then going back and ripping the beta hydrogen off of the molecule to do E2. I mean, it's not true, but I think it works as an analogy. Their first attempt is substitution, and when that can't happen, they go back and they do E2. Okay. So that's the case here. We know tertiary halides cannot undergo SN2, right? Because they're tertiary halides. They're too sterically hindered to do SN2. So this alkynyl anion comes up, tries to do SN2, tertiary halide says, sorry, don't do that. And then the base comes back in and rips the beta hydrogen off because it's got to do something. So remember, if we've got our alpha carbon attached to the leaving group, and then we've got our beta carbon with our beta hydrogen attached to it. So this minus comes in, grabs the hydrogen, the pair of electrons moves there, and then kicks off the chlorine. So a standard E2 mechanism. In this case, since there's no ring, we don't have to worry about whether the hydrogen was cis or trans to the leaving group because there's 3 hydrogens there and they all could rotate to become trans or anti to the chloride. So we end up adding a hydrogen to the carbon, and then we end up forming the double bond, the alkene. And in this case, since all 3 beta hydrogens are the same, doesn't matter which one we deprotonate. So this is the first one of the strong nucleophiles that can act either way. Because we avoided those last semester. But is everybody okay with that? So primary, secondary, they'll do SN2s. Tertiary, they're going to do E2. But remember, when we do E2, we have 2 possible choices for products, right? We've got the most substituted double bond, and then we have the hydrogen that's least sterically hindered being removed, which oftentimes leads to double bond being less substituted. The Zaitsev product versus the Hoffman product. So here's my question. How should we treat this alkyne? Should we treat it like NH2, where it can get to any of the hydrogens and it's going to form the most substituted product? Or are we going to treat it as if it's sterically hindered and it can only get to the hydrogen that's least sterically hindered? What do you think? Bill?
Is it linear? Is it like NH2?
Not going to be sterically hindered? Do we agree with that? Sound good? I think did I say that earlier? I know, that's why I mentioned it. Because this is where it comes into play. The idea that a linear sp hybridized triple bond is not going to be steric. So we're going to treat this as if it was like an NH2 minus, which means the product that we're going to form is the more stable, meaning the more substituted, the more stable should go here. The more stable, the more substituted, double bond. So that's how we handle alkynyl anions, and the idea of alkynyl anions is you're making a triple bond, but you're making it from another triple bond. So what we really need is we really need a way to make it from scratch, Kevin.
So you're picking the most stable, but all three of them are equal, right?
Yeah, the double bond could go to the right, it could go down. In this case of the terse butoxide, in the case of the terse butyl chloride, it wouldn't matter which hydrogen I removed. I think in the homework problem, I've given you that one to react it with. And so there you want to make sure that the double bond that you make is the most stable double bond. And whenever we have these nucleophiles that can either be nucleophiles or bases, we'll have to determine when will they act as nucleophiles, when will they react as bases, and when they act as bases, are they going to be small bases or sterically hindered bases? Okay. Right. So that's one synthesis of a triple bond, but it's pretty boring. I know, not for the first day, but what's more interesting is this. Let's say that I take that double bond and I add bromine to it. And so if I take that double bond and I add bromine to it, what kind of product am I going to get? What? You said trans. That's part of the answer. So if we go back to last semester, when you add bromine to a double bond, okay, boy, this is going to probably give you nightmares. What do we add to the double bond? We add 2 bromines. How do we add them? Markovnikov or anti-Markovnikov? Doesn't matter because it's 2 bromines. How do we add them? Cis or trans? Trans. Why are they trans? The bromonium ion might still be there, which is good, right? We want to make sure it's there so we can do that. But I'm going to add 2 bromine strands. So, great. Now this is an acyclic system, so there isn't really cis or trans because there's free rotation, but I'll write it that way. Uh-oh. I'm going to make a modification here. How are we going to make a triple bond out of that? Because I'm not just off on a tangent this time. So the way we make a triple bond from scratch is that I'm going to treat this alkyl halide with 2 equivalents of NH2 minus. And so what's going to happen is the NH2 is going to come over and grab the first hydrogen, and then the pair of electrons goes here and the bromine leaves, so that I end up forming a double bond. And then I need a base strong enough to rip this hydrogen off to do a second E2 elimination. And so that's why I use NH2 minus, because it's strong enough to do both. So then the second NH2 minus comes in, grabs that hydrogen, the pair of electrons goes there, the bromine gets kicked off, so that now I made my triple bond. And we're going to do more of this on Wednesday. But this is the way to make the triple bond from scratch, is to do a double elimination on what's called a 1,2 dibromo alkane. But where did the 1,2 dibromo alkane come from? Last semester.
Does the hydrogen that's being ripped off in the second reaction have to be donors?
It's got to be trans. Okay. So we'll do more of that. So we'll finish this up and then we'll do the reactions. So what I want you to do for Wednesday is, again, watch the video or look at the textbook for the rest of chapter 13. You're probably going to want to go back and take a look at the video for today as well. And then on Wednesday, we'll start with any questions about those reactions. So on your way out the door, you can grab your